Welcome back to Stewart Science. Today we're going to be talking when we do our experiment, how many groups of numbers should we have, how many times should we try each experiment. There's just a lot of thought that needs to go into our experiment. If we just do one sample, we try two different things, that's not going to be enough data. So how do we get a good enough amount of data? What do we do with our observations and our numbers once we get them in order to show a good relationship? So I got to start by saying the point of our experiment is to connect our independent variable to our dependent variable. Once we change the independent variable, or what I call the manipulated variable, how does our dependent variable respond? So we should be, if we're doing a good or easy scientific experiment in our lab, measuring two things so we can find a relationship. If we can get a numerical relationship in some way, to put some numbers to it to help us make good predictions, that would be the best case scenario. Not all questions, not all experiments let us do that, but a lot of the ones that we're going to be doing in ninth grade science will allow us to put some numbers to it and find a good relationship. That way we can make predictions with that data. So first, let's do some definitions like we always do, and then we'll do some examples. So the first question is, how many things should we test? And again, this is going to be determined by your question. Every experiment is going to have a different answer, but most of the experiments that I'd like us to do in the lab are going to be changing one thing that has numbers to it and seeing how some other thing responds. So if you're in my class, we do a lab every year where we take different balls, like a tennis ball, a racquetball, a basketball, a bouncy ball, and we drop them from different heights, and we measure how high the ball bounces back up to. So we're changing drop height, and we can change it by 1 centimeter, we can change it by a whole meter, we can change it by 10 centimeters. We have control over that. That's our manipulated variable. And so I usually say go in about 10 centimeter increments. We can go 20, so you go 20, 40, 60, 80. How many different heights should we do is always the question that I get when we do that experiment. For my class, my guideline, if it's possible, I want to see 8 different groups. If you're changing something that has some numbers to it, go for 8 to 10 different, they're called sample groups, different independent variable groupings. If you can't do that, or if that's going to take all day, or if you get to the end of a class period and there's only like 5 minutes left, as long as you've had 5 different samples taken and they're measured well, I'll take that. So the answer that I'm looking for here, how many sample groups, how many points am I looking for on the graph? I'm going to say 8 to 10 if possible. Now, some experiments, if you're doing like Are Boys Smarter Than Girls, you're only going to have 2 categories there. So we'll talk about what to do with categorical data in another video. Next question is, how many times should I test each one? And again, the answer to that question is going to be determined based on the question that you're trying to answer with your experiment. So some things change from sample to sample to sample, and some things don't. For example, I've used this before. I'm 6'2". I have been 6'2" since I was in 10th grade. I'm 32 years old. That's not going to change anytime soon. It hasn't changed in many years. You don't need to measure my height several times. I'm not going to get bigger or shorter between measurements. Not going to change. I'm 6'2". Some things do change. So I mentioned before we do drop height as our independent and bounce height as our dependent. Every time you bounce a ball, it's going to bounce up a little bit differently depending on how you let it go, depending on how you dropped it, if it hit the ground and it was spinning. So little bitty things are going to have a little bitty difference in your measurements. And so I'd say 3 to 5 times. Take each one 3 times. If it can change from sample to sample to sample, try it 3 times and then take an average. So, how many sample groups am I looking for in your graphs? 8 to 10. How many times did you try them? 3 to 5. So bare minimum, you should have 24 individual points if it's possible. And again, if you're a little short on that because you ran out of time in the classroom, okay, that's what we got. So here's an example that I'm talking about. The reason why we need more than just 3 points that you take one time. First of all, if you just take the sample one time, you could have made a mistake. If you take it 3 times, you get the same thing or ballpark the same thing each time, that's a much more reliable point. But let me just put 3 points on this graph. Now my question to you is, what kind of relationship is that? Is that a straight line or is that a curve? So they're obviously going up as the independent variable gets bigger, so does the dependent. That's a pretty obvious connection here. But the question is it a straight line? That doesn't look bad. That line goes through most of my points. Or is it a curve? And that doesn't look bad either. I mean, my drawing is a little above the points, but you get the idea. The question is it a straight line or a curve? And I don't think from only 3 points that we have the ability to actually answer that question. So I need to add a bunch more points. If we add a few more points, that's looking pretty curvy. That's a lot better. That fits our data a lot better than a straight line. The points were a lot closer to that curve fit. And so we need to get an accurate picture of our relationship, and to do that we need 8 samples at least, taken 3 times each. So how many sample groups? 8 to 10 if you can. How many times each? 3 if it could change. This is Mr. Stewart. As always, keep learning no matter what.